Evaluate divisibility rules for numbers beyond 7 up to 10. And today we are going to see the importance of that as we apply them in prime factorization. Prime factorization is a key component that indirectly we use mostly in our evaluation of sets. So this one is a key tool that will help a beginner, someone, even people that forgot about prime factorization. We will need to revise that because we need that in this topic silently. So let's get to the whiteboard. Get to what at all is prime factorization. So you remember in back in high school, junior high school, they will ask you to find the prime factorization of 12, for example. So we are going to do it for 12, do it for 18, try it for 24, 27, 32. Then let's pick a random big number like 1, mm, 2, 3. Yeah. And another one, 1, 1, 7, for example. Yeah, try to find the prime factorization of these numbers to illustrate what we mean by prime factorization. So let's start with 12. So we are facing the number 12 and we need to find the prime factorization of this number. So we need to write it in terms of its prime number. And so in the word prime factorization, we have prime. So we talked about prime numbers earlier. So let me list them again. So we have 2, 3, 5, 7. Yes, so these are the basic one that we'll be using now. While we have other prime numbers as well. So if you continue, you are going to see numbers like 11. I think 17 is next one. Yes, 23 follow up like that. 19 to 19 is between 23, so 23 is also one of them. Yeah. So I think this is the one we'll be using mostly. If it goes beyond, we might use before 19, before 17 there is 13. 13 to is there that we need to use. Yes. So yeah, if we go beyond them, we are going to use the other prime factor. But mostly these ones, by the time you use all these ones, then you'll be able to get the prime factorization of the given number that you have. Let's start with 12. How do I find the prime factors of 12? So we need to actually divide the number, right? So this is the number. We need to actually divide it, do division of the number. So how we divide it? We are going to divide by one of these. We start with 2 going backward. We start with 2 of the prime number going backward. Is it forward or backward? So let's see how it's done. So first you need to check if 2 can divide this number. 2 can divide this number. If you watch the previous video, you know that 2 can perfectly divide this number because it ends with an even number. The divisibility rules. That was why we had to spend time learning that. So if you learn the division, you see that 2 can enter this number. So 2 enter this number thing and give you 6. So the result that we have now is 6. So the next one, then 6 now become the number that we are dividing now. So you need to start again. Can 2 enter this number 6? You see that 2 can still enter this number 6 if you learned from the previous video. So 2 will still enter, then you get 3. Now let's take 3 as the number that we are dividing now. Can 2 enter 3? No. Can 3 enter 3? Yes. So you write it 3. 3 will enter 3 once. 3 will enter 3 once. So finally at this point, we've gotten 1. The point where you have obtained 1, you don't need to proceed with the division again. Basically, what we do is that we took the number 12. When we did the division, we had 6. So we now focus on that 6, which we sent here. Then we do the division. When we do the division, then we send that 3 here. Then we choose the perfect prime number that will divide it like that going forward. So at the end of the day, we look at all these numbers, all these prime numbers that we use to divide at the end of the day. So we use 2 of the 2's and 3. So we use 2, we use another 2, and we use 3. So let's try to go like this. 2 times 2 times 3. So you see that you have 2 times 2 times 3. They were the one that we used. We use 2 first, use another 2, and use 3. So these are the prime numbers that we use to divide this. So they come together to form the prime factors. So the prime factorization, you see 2 and 2, they repeat. 2 and 2 repeat. So since they repeat, we are going to do 2 squared. So the 2 repeats how many times? Twice. That's the power there. Times 3. So at the end of the day, the prime factorization of 12 is 2 to the power 2 times 3. Don't worry if you don't get it now. We'll use another example. So the next example is 18. So we have to find the prime factorization of the number 18. So let's take 18. We do the division. 18. So we start with the prime numbers. Which prime number are we going to choose? We start from 2 going forward. So 2. Can 2 enter 18? Yes. What are we using? The divisibility rules. It's in the previous videos. So 2 by 18, you get 9 perfectly without a remainder. So now we take that 9 now. We now take the result that we get. We come now the new number that we are dividing. So we check. We go back to our prime set again. Can 2 enter 9? No. Can 3 enter 9? Yes. So we now divide by 3. 3 will enter 9 how many times? 3 times. So yes. Now we use that 3 as the answer that we got from the previous division. So it become 3. So this number, this new divisor, we now go back to our prime set. 2, can 2 enter 3? No. Can 3 enter 3? Yes. So we now enter another 3. So remainder 1. So when the not remainder, the answer is 1. The moment the answer is 1, we need to stop there and just take the numbers that we used to do the division along the way, which is 2. Yeah, so 2 times 2 times 3. At the end of the day, we have 2 times 3 times 3. So because 3 repeats, we are going to have a 3 squared. So you do 2 times 3 squared. Remember that we are writing in increasing order of the prime numbers that we use to divide. So 2 by 3 by 3. So at the end of the day, 18 is equal to 2 times 3 squared. This is the prime factorization of 18. Now, I want to state something. When I was doing the division, let me use this for example. I didn't complete the division fully because I see the number perfectly enters the 18, the 12. So 2 enters is 12. 2 times 6, 2 times 6 is 12. So the remainder is 0, 0. So the remainder is 0. So even when the remainder is 0, then you proceed taking the continuous answer. Because we've learned divisibility rules already, that's why we know that it enters perfectly. So I took the number. So if you haven't watched the divisibility rules, please do go
Miss
back.
the next concepts. Why don't you subscribe to keep notified of new videos and concepts?
Please do go back and watch. The next number should be 24. So let's see. Divisibility by So number 24, we go back to our set of prime numbers. 2 can divide, right? That's the first one. We always start with the least one. That's 2. So 2 can enter 24. It will give you 12. And then so we take our new 12 as the number we are dividing now. 2 still enter. So anytime you are starting a new division, you need to go back and test for every number that can enter the number that we are dividing. So 2 enter, we have 6. So yes, we take that 6 again, go back to our set. 2 will still enter, so you write 2, so we give you 3. Now we take that 3 now. You stop when you reach what? 1. So 3. So which set can we take? 2 cannot enter again. Now we go to 3. 3 will perfectly enter. So you go to the left one. So we got the answer, final answer to be 1. At that point, since we got 1, we need to stop and then take the numbers that we have used so far to do the division along the way. So it's like we use 2 times 2 times 2 times 3. But the 2's repeat. Because they repeat, you can just write they repeat how many times? 3 times. So we write that at the top here. The number of times it repeats, we write it at the top as the power times 3. So at the end of the day, 24, the prime factorization of 24 is 2 to the power 3 times 3. So this one I wrote 21, sorry. So 21, let's try 21. 21 divided by, okay, 2 cannot enter 21, we know that. But 3 can enter. 3 can enter because if you sum the digits, you are going to get 3, which is divisible by 3. So yeah, 3 can enter. So if a 3 enters 21, we are going to get 7. Now we take that answer. We see that A 7, right? So 2 cannot enter 7, 3 cannot enter 7, 5 cannot enter 7, 7 can enter 7. So we pick 7. 7 divided by 7, we get 1. So the answer that we get are finally 1. So we now take the numbers that we used to do the division so far is 3 and 7. So 21 is just 3 by 7. That's all. So what I will do now is I'll leave the rest to you. When you're able to complete it, I'll leave this and this to you to complete them. Then I'll do the 117. And then when you are done, you practice other examples that any number that you have around, so you find the prime factorization. Prime factorization is very helpful. So you see how we learn the things. We first look at what prime numbers are as a prerequisite. Then we also look at divisibility rules. And then the divisibility rules are helping us to do our prime factorization easily. So as I said earlier, it's a process. Don't just jump over the videos or don't just jump from one concept to another. Try to follow. Try to follow and grasp the basic concepts before we tackle the main topic, because all these tools are going to be helpful in order to master set, no matter how difficult it is. So let's see. The number that we are having now is 117. So I'll use 117. I'll ask myself, can 2 enter 117? No. According to the divisibility rules, 2 cannot enter. Let's try 3. 3. 7 plus 1 plus 1, that's 9. So 3 can enter 9. So yeah. So 3 is going to work. So 3 will enter 11. 3 will enter 11 3 times. So it's going to be 3 times 3. That's 3 times 3, that's 9. So remainder 2. 27. 3 will enter 27 9 times. Yes. So 27. So now you finally got our number 39. We now take this new 39. Remember, we had to proceed because what? The remainder is what? 0. And we knew that 3 will perfectly enter this number from the division, so we don't have to waste time. So we now take the number 39. With 39, we need to check again. 2 will not enter, 3 will enter. So since 3 will enter, we now do 3 will go into this 1. 3 will go into, that's 3. Now 9. 3 will go into 9 3 times. 3 times 3, 9. Complete. So you now have the number 13. You see, the number 13 is part of the prime numbers. You see, when you had 7 as an answer, 7 was part of the prime numbers. So you see that you just pick it up indirectly. But I didn't want to show it like that, so I had to just take it again. So 13. So among all the prime numbers, we see that only 13 can enter. So 13 will give you a perfect one. So the number that we use so far are 3, another 3, and another 13. So the number 117 is a combination of 3 times 3 times 13. But the threes repeat. Since the threes repeat, we are going to write them as 3 squared times 13. Yes, this is how to go about the prime factorization. And I leave the 32 and the 123 for you to evaluate. You can put your answer in the comment section. We'll look at it and give you the feedback that you may need. Thank you very much, and see you in the next video as we explore indices, basic indices. Thank you very much.
Do not miss the next concepts. Why don't you subscribe to keep notified of new videos and concepts?